Let's dive into our second example, where we are going to attack the box OpenAdmin. As before, be sure to note the IP address here in Hack the Box, as the IP address I have on my screen may or may not be the same IP address for you. In the first example, we learned that an attacker is likely to run an nmap scan as the first part of their enumeration. So we can begin constructing an nmap scan of this machine to find out where we should start. Let's start by typing in nmap, passing in a -a and a -pn, followed by the IP address. Hitting enter, nmap will take a few minutes to run this scan. We can see that nmap has caught two open ports on this machine, neither of which is very surprising. The first being port 22 to connect via SSH, and the second being port 80, and it appears to be hosting an HTTP web server. Now that we know this machine is hosting a website of some kind, let's run a nikto scan to see what other information we can find out about it. We can type nikto --host followed by http://. And since there is no domain name, we'll simply use the 10.10.10.171 IP address, which defaults to port 80 since it's HTTP. And we can hit enter to let this scan run. Now that nikto has returned the results, let's take a look at what it found. Scrolling up, we'll see that nikto confirmed our target IP. It did not find a host name. And it identifies Apache 2.4.29 as the server hosting this particular website. A little bit further down, we'll also see that nikto warns us that the version of Apache running is not the latest version of Apache possible. This would immediately catch an attacker's eye, and we could probably Google to see if Apache 2.4.29 has any known vulnerabilities. We do find a handful of CVEs associated with Apache 2.4.29. But in the interest of moving along with this example, I can tell you that this version of Apache is not the problem on this machine. Nikto also warns us that various HTTP headers are missing from the data returned from the server. In this example, none of them are particularly interesting. And we can see that the Apache default file was found. So why don't we pull the site up in the browser and take a look? For an attacker, finding a web server that's hosting the default Apache files is probably an indication that the network administrator didn't configure the website being hosted as efficiently as possible. Looking at the source code for this page, we can scroll through and see all the CSS and HTML that come with this default Apache page. And again, in this specific instance, there's not really anything interesting to find here. Since neither nmap nor nikto nor the browser have uncovered anything interesting, it's time for us to try a new tool. Allow me to introduce you to gobuster, a command line brute forcing tool to help identify files and folders that are available on a website. Like many CLI tools, gobuster can be configured with all kinds of options. For this example, let's type gobuster followed by dir-u and the location of the website that we want to brute force. The dir in this command tells gobuster that we're looking at brute forcing open directories. We also want to attach a -k to ignore checking the SSL certificates of the website, as well as a -w pointing to a word list to use for brute forcing. And in this case, we're going to use /user share derby word lists common.txt. And this is a file that's built into Parrot OS as well as Kali Linux. And you're free to use any word list that you might like, though this common word list is something that I would recommend to do a quick scan. Hitting enter, we can see that gobuster not only executed this command really quickly, but it also found some interesting results. Scrolling to the top, we can see that it found a .hta, a /artwork, htaccess, and htpasswords, although these are returning a 403 for unauthorized. It found an index.html, which is the page that we see here on the right, a /music directory, as well as a /server status, again with a 403, although this result is also typically something present by default on Apache web servers, unless the administrator has disabled it. This narrows down the possibilities for our attacker to look at artwork and music as potential targets. So coming into our browser, we can type in artwork, and what we find is a website that we can begin to enumerate. While we won't go through the enumeration in great detail for this example, an attacker will certainly click through each of the individual pages, and they'll look at the source code for each of them. As an example, we can see all of the various CSS files that are being loaded by this website, many of which relate to Bootstrap and jQuery, which is fairly common for websites. Things like Google Fonts are being loaded from a third-party domain. And we do have some styles that are presumably written by the developers of this website. Scrolling through the CSS in this file, we don't see anything interesting, so we'll continue with our enumeration. Continuing to scroll through the site, we can see a variety of other HTML files that are linked from the user interface. And one of the things I like to do when enumerating a website myself is to look at all of the links in the source code. Sometimes what you'll find is that even though these anchor tags may exist in the raw HTML, CSS or JavaScript may be hiding them from us in the user interface. Continuing to scroll through, we see some other images that are being loaded. And in fact, there's an images folder, which might tell us to go and explore whether or not this directory is open for viewing, which it is. As a side note, if you are hosting a website using a server of any kind, you should not allow general internet users to browse the open directories of a site because they may be able to find files you didn't think were important. Continuing to scroll through the source code of this application, we can see some lorem ipsum text, which tells us this is probably some generic website template that this developer chose to use to build this site. So a lot of this text will just be nonsense and therefore we can ignore. Although perhaps Craig Stephen would be an interesting tidbit to write down in our notes. As an attacker, we will certainly be trying to enumerate any and all users or potential users of a website, an application, or the underlying infrastructure, employees who work for the company, etc., and so forth. As we scroll all the way down to the bottom of the page, we'll start to see things like an email address that might be embedded within the HTML footer, and additional files linked for JavaScript. Typically, these JavaScript files are loaded at the bottom of an HTML document, which is the opposite of what you typically see with CSS files. But we can, instead of going to /images, maybe we come into /js, and we can see all of the JavaScript files that have been deployed onto the server. Similarly, we may choose to go through the raw source code of all of the JavaScript files. What I've seen here is obviously jQuery code. You can see different selectors being used in the jQuery syntax here. As an educated web application developer, I know that jQuery code that is written and deployed to a website in this fashion, where you're sort of willy-nilly grabbing elements on the page and adding click handlers and things like that. This example here is simply adding or removing a class if something has been clicked. So to an attacker, a lot of this JavaScript code isn't very valuable because it's not going to really tell us how to do things like take advantage of a cross-site scripting attack. A lot of this is just presentational JavaScript. Again, things like a slider range just probably goes to some kind of slideshow that's running in the user interface. Now that we're at the bottom of this file, I can say I didn't see anything that immediately jumped out at me. So as an attacker, I would simply continue enumerating. Well, we've looked at the artwork site quite a bit. Perhaps it's time for us to switch gears and go over to the music folder that we also saw in our gobuster results. This folder clearly contains a separate website, and again, our process as an attacker will be to enumerate this website in its entirety to find as many puzzle pieces as we can find. So clearly we will do things like look at the page source code here, and we'll see what we can find. One of the first things that jumps out at me is this login link is going back a directory to a directory that we didn't know about before, this ONA. So if I were to come into the browser and type in ONA here, what we'll find is a dashboard. We aren't entirely sure what this is yet, but the fact remains we have identified a folder on the web server that we didn't find using automated tools. It certainly does prove that automated tools, things like gobuster specifically, are only as good as the word lists you choose to feed them. It also underscores the importance of manual enumeration, being able to identify parts of the code base that should be most interesting to an attacker who's looking for the puzzle pieces to create a picture of vulnerabilities that they can attack. So let's try to figure out what we have here on the screen. We can see a version number, v18.1.1, and the application tells us we are not on the latest release version. The question is, what are we looking at? And if I were to click on this link, you can see down in the lower left corner, it's pointing to opennetadmin.com/download. Well, an attacker certainly would go and look at the source code for perhaps the latest version or even the version that we're looking at. For the interest of time, why don't we just Google v18.1.1 of OpenNetAdmin and see if there are any known vulnerabilities. The very first result in Google indicates there's a remote code execution exploit that's hosted on exploitdb.com. We can either download this exploit by clicking one of the buttons we have here, or we can scroll down and take a look at what this exploit does. It appears that it's a bash script that is going to execute some sort of curl request against the target. The general idea is that by issuing HTTP commands against this OpenAdmin application, we can execute code on the server from our remote attack machine. It's not quite a full shell, but perhaps it could enable us to pivot from our own machine to a full-fledged shell connected to our target. Let's simply grab this code, copy it, and come over to our pwn box. For the sake of example, I'll make a directory and we'll call this OpenAdmin, which is the name of the machine that we are attacking. And we'll cd into there, and we'll touch an exploit.sh. We'll paste this code into our file. We'll save it, and we'll make it executable. Now that our script is executable, we can simply run it using exploit.sh and then provide it a link to our vulnerable application, which is running on 10.10.171/ONA. And while it's not clear in the exploitdb code, we also need to pass it the login.php file, which is the vulnerable piece of this application. What appears now is something that resembles a shell. We can see the blinking cursor and the $sign on the left. Even though this is not a real shell, I should be able to run a command like who am I, and it correctly returns that I'm running a www data user on the remote machine. I could run something like ID, so it'll tell me the user groups that this user is a part of. And maybe I could even do something like a cat etc password to see what users are on the box. And we can see things like Joanna, MySQL, and Jimmy being the most reasonable pieces of information to pull out of etc password. The OpenAdmin box here on Hack the Box has even more goodies the further you continue to escalate your privileges inside the machine. But the lesson to be learned here is that having a vulnerable web application, again, third-party code with a known exploit, can be incredibly dangerous, not only because it leaves the web application wide open to attack, but now the web server itself can potentially be breached. Thankfully, we had gobuster helping us to identify folders on the server we wouldn't have known about otherwise. Let's use all of this knowledge in the next lesson to attack another vulnerable machine here on Hack the Box.